Okay, so the recording should be started. Welcome to the Math 140 Guided Study Group. My name is Liv. I'll be your Guided Study Group leader for this semester. I have been doing this. This is my 4th semester doing guided study groups, but it is my 1st semester doing 140. So it'll be a little bit of a learning experience for me just to like see the pace of the class. I also, unfortunately, do not yet have a book for this class. I thought that I did, and it turns out I had the wrong book. So I will have to get my hands on the book that y'all are using, but unfortunately that means that usually how I run these things is we kind of open it up for questions on the material that we've been discussing in class, and usually there are very few because people, it's just like not like the first thing that comes to mind. So what we do instead is practice problems just to see what questions kind of arise. Are those questions that you have from the book? I don't have the book, so I can't do that right now. If you can write them out, that would be a-okay by me and we can work through them. But that's what makes it really hard today in particular. Also, I don't know if those are your guys' homework problems, but I do try to refrain from doing your homework problems. Instead doing problems that are pretty similar to them. Anyway, so that's kind of how the shindig goes. Usually I will have the book and can like give you page numbers and stuff and what problems I'm doing, but unfortunately that's not the case today. That being said, this week is kind of like a little bit of an introductory week in that there is not like a huge amount of content that we kind of sunk our teeth into. So I'm not really anticipating this to be very long. I think the one this morning was pretty short too, just because there wasn't a lot of stuff. But if you guys have any questions, please feel free to ask, drop them in the chat box. If you'd like to turn on your mic and ask a question, like via your mic, just a reminder you will be recorded, but that's a-okay too. So yeah, if there aren't any, then I have some practice problems in a book that you guys don't have that we can kind of do a little bit. Because you guys are doing limits. I will give Alexander just a couple seconds to finish writing out those problems. So let's just like take a minute. Okie dokies. All right, so that's really sloppy. I do try to make my handwriting legible, but sometimes it isn't. And if it isn't, just yell at me in the chat box and I will fix it. I'm assuming it looks something like this. Um, okay. 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 So let me see. Plus 7 t at the end of this little shindig. Oh, in here. Awesome. Okay. So I think that's the actual problem now. Alrighty. So basically the way that, like, what is tripping you up on this? I don't want to like start from like okay. So in the chat box, he's describing how he started the problem. So I'm just going to write down exactly what he's got right now. Well, first things first, if we're gonna like start to work with the denominator, let's just see if we can factor it into something. Well, we have this 2 here. So when I'm looking at it, I see maybe 2t. Let's try that. Minus 4. I don't know why I put 4 there. Why are you saying 2t minus 4? Because we've still got to have these multiply to 3. So let's do. Oh, but that adds to 7. There we go. I don't have a minus. So that's 2t squared plus t plus 6t plus 3. Yeah? Yeah. So the issue you were running into was just simplifying that denominator. So it's good. I don't know how we ended up with x's and t's. I'm just going to change that to a t, and that's going to be a t. So now we have the limit as t goes to -3, and we're going to have t minus 3, and then t plus 3. Here is 2t plus 1, t plus 3. These are going to cancel out. Yep. So then you're taking the limit of this much simpler problem right here. And there we're just going to have t approaching -3. T is again approaching -3, so that's -6. So, -6. Yeah. Cool. Yeah. Cool. Cancel out those negative signs, and there's our limit. Alrighty. So what problem number was that? Just so that I can write it down so that everyone else can kind of see it. That was number 15 in the book. So yeah. Question 5 on the self-assessment. Problems dealing with absolute values. Gotcha. All right. Let me clear this. I'm going to open up the self-assessment. Because I think I have access to that. Wait, is this a quiz that y'all have to do? Okay. Oh, I do have access to it. Okay. So, question 5. I don't know if it sorts these. Oh, no, it doesn't. We've got an absolute value in there. All right. So, that is... Right? Is that the problem that you're talking about? Cool. All right. So, the way I would do this is I would start off by factoring this top portion. So we end up with something that looks a little bit more like this. That's an excellent, yeah. Well, this is 6 from the right, isn't it? Yeah. Sorry, I'm a little bit rusty on some of this stuff, and I did not get to use the book to do as much review as I would have liked before coming into this. So I'm sorry if I'm a little slow this week. I promise next week I'll be on my A game. But I might be a little bit off today. Starting off like this, if we're thinking about x coming in from the right, coming in, approaching 6 from the right, then this chunk down here is going to be negative, yeah? But it's the absolute value, so it's always going to be positive. So it doesn't really matter, does it? Well, this is an absolute value here. So, and then this one, yeah, this one will always be negative if it's coming in from the right. Well, if we were looking at a problem that was saying x and 6 was approaching from the left, then 6 minus x, where x is approaching 6 from the left, this is going to be positive, right? Because it'll be like 5.9, 5.99, 5.999. All right, what are you saying about this 6 minus 7 thing? Yes. So we have 6 minus a number that is larger than 6. Yeah, so negative. So this is negative. This one here is negative. And so this one here is positive because it's an absolute value. And so regardless of what goes in, the absolute value is going to be positive, right? So yeah, I have a tendency to break things down into like the simplest form that I. Six minus 6.999 is, yeah, negative. I have a tendency to break things down into like the more simpler forms that I can. That makes our denominator approximately 0. So there's still more work to do to solve this problem. But I kind of started off by like seeing, because it's a limit, I just kind of wanted to see what would happen. A lot of times there are problems in calculus, like if you walk in and you try to solve this problem, like you hit that wall where in our denominator it's going to be approaching 0, which means it'll be approaching infinity. This whole thing will be approaching infinity, and this will theoretically be approaching 6, but I'm pretty sure we have to split it more. Is this done? Is it just going to infinity? It might be. Because we're dividing by 0. But it's 0 coming in from the positive direction, and this is always going to be negative, so negative infinity. It says the answer is -2. Well, clearly, this is wrong then. So let's see if we can work towards -2. I'm so sorry, guys. Okay. Let's do some problem solving here. Rules of absolute values. I haven't worked with this in a hot minute. They tend to throw things like this on there as like kind of trickish problems. Like these are kind of the hard ones with the rules that you haven't used in like 3 years. See, I feel like you should be able to in some way, shape, and or form. And then I guess that's just, yeah, since the numerator is negative theoretically. So you have to think about the signs. So this, let's call this whole fraction negative. And then if we get rid of those, so we move that negative sign to the outside, and we've got -2. Okay. Whoever said that was right. So, yes. I'm going to write this down a little bit more explicitly just so that I can kind of like process it, and hopefully everyone else can as well. So what we did is we had the limit of x is going to 6 from the right, and we knew it was going from the right, so we knew that this was going to be 2, and we knew that it was going to be 6 minus x, and we know that this sign up here is going to be negative. And this is going to be 6 minus x, and this is going to be positive. So basically what we knew is that this whole fraction was going to be negative, and we can get rid of this because we have a negative divided by a positive, and then we were able to cancel out these. So our answer, the limit of x approaching 6 from the right, is negative 7. So yeah, sorry, sometimes I just kind of need to work through it, but a good question. Other questions about problems that we were working on this week? Review questions, etc. Have you not had an infinity answer yet? You have? Okay. So basically, the idea is if you have like some number, I'm picking 5, and you divide it by a very, very small number, that number gets bigger, right? So this is what? This is 10th on 1,000. So the limit along the x moves towards infinity, up or down towards negative. What are you saying? Are you kind of explaining? Okay, yeah, you're kind of trying to explain like what's going on with, yeah. Okay, so one way to look at this is 1 over 1,000, right? So what you can write this as is 5 over 1 divided by 1 over 1,000. And in order to like multiply fractions, what you can do is you can just like swap them, if you remember this. So you flip this one around, take the reciprocal, and you end up with 5,000. So there's like one example of we have a big regular number being divided by a tiny number to yield a big number. And so basically what this is, like this getting an infinity answer, is what happens if we were doing approximately 0. Like this number is so tiny that it's like basically 0, but it's not 0, but it's basically 0. How big would the number in turn get if we're dividing by such a tiny number? Like we're cutting pie slices infinitely small, like just tiny, tiny slivers of pie so that we can divvy the pie up around like with infinity number of people. Like harkening back to the days where we were slicing up pie to understand fractions. It's like grown-up version of that, in that we have this very, very tiny number in the denominator, and we're making it very small pieces of pie so that we can feed an infinite number of people. So that's kind of the concept behind this infinity thing. And the way that it becomes negative infinity is if it's negative 5. There's really no pi example for that because real world examples don't get too happy with negative numbers. But yeah. Does that kind of help you understand how an answer can be infinity? Graphs? Okay. Okay. So let's see. Let's come up with a type of, yeah, sure. Let's come up with a type of, okay. So here's like a kind of basic like example. So we have this function f of x is equal to 1 over x minus 4, right? When x is equal to 1, f of x is going to be equal to -1/4. Or when x, when x is equal to 0. So this is, let's go x is equal to 1, that's -1/3. I cannot clearly draw a graph to save my life. -1/3 is going to be larger or more negative. -1/2. That's, yeah, they should. It's cool. So this is 2, and then 1 over 2 minus 4, or -2. And then 3, -1. And then, what are we going to do when we hit x is equal to 4? Graphically, what's going to be there is what's called an asymptote. So x cannot equal 4, because then we would be dividing by 0, actual 0, and that's a big no-no. So instead, what we're going to do is we're going to get really, really close to 0. And we are approaching this from the left while I'm graphing this. So we're approaching -4 from the left. So it's going to be under 4. So it's going to be 3.99 minus 4, right? And so it's going to be negative. So as x approaches -4 from the left, this is going to be like 3.999 minus 4, and we're going to end up with 1 over negative approximately 0. Or the limit is equal to -infinity. And graphically, it just goes straight down, essentially. So basically, that's what's up here. Then if we go back to looking at like x is equal to 5, we get x is equal to 5 hanging out up here at 5, 1. And so now let's take a look at if x approaches 4 from the right. Well, it's going to be 1 over approximately +0. So we're approaching 0 from the right, so it's positive. So the limit is going to be equal to +infinity. And so it's going to go up in basically a straight line. It approaches the asymptote, but never touches it. You can see I drew it touching, but that's bad. That was bad on me. Just because I'm sloppy. never actually touches the asymptote, because in theory x can never actually equal 4, because that would be dividing by 0, which is like dividing by real 0, which is a big no-no. And that's why I always went through right here and put approximately 0, because yeah, we're dividing by 0 to get infinity, but it's not like real 0, it's almost 0. It's so small that we can assume it's 0. Okay. Are there more questions about this type of thing? Positive infinity, negative infinity. Lots of stuff. Okay. We had a request for a problem earlier. Did this help with that? Yes, no, maybe so. Okay. I'm going to clear this. Are there any other questions? Awesome. Okay, so did you guys turn in your homework already? Oh, awesome. Okay. Then yes, I can do that. And where is your homework? Oh, is this on WebAssign? Shoot. I don't think I actually have access to the WebAssign. Okay, and the in-text recommended ones? Again, I don't have a book, so I can't actually do question like 12 from the book unless somebody wants to actually go through the trouble of writing it down right now. And again, I'm so sorry. This is not what I planned. This is not how it usually goes.
Can you hear me?
Yes.
All right, number 12, the limit as x approaches -3. In the numerator, we have x squared plus 3x. In the denominator, we have x squared minus x minus 12.
Alrighty. Sweet. Thank you. Cool. So first things first, let's get this as simplified as we can, right? Because we don't really want to deal with like this monster. So first, I'm going to factor out is this the problem we want to be doing? All right, I'm just going to keep doing this problem.
Hey, can you hear me?
Yep.
Hey, I don't know if I'm in the right spot. I'm having trouble with using WebAssign. Very wishy-washy using it. Not sure if I'm in the right spot. So where I looked up for question 12
Okay.
was under my assignments.
Yeah, if you guys are on WebAssign right now, I do not have access to what's going on WebAssign. So you can tell me what the problem is, but I can't get onto WebAssign to check.
All right, let me ask a question, Alex. When it comes to these questions that you're referring to, though, in the book, how did you access like the book directly? Because I'm still having trouble with this. With my job, I don't have a lot of time accessing
I got you.
this week with using WebAssign.
So I bought the book separately, and then I realized I needed the WebAssign, and then you have to buy it from I think it's like Cengage Unlimited. separately.
Right.
And then so I did that, and then that should come with a textual version as well that you can look through, online version.
Yeah,
Yes.
I think by the section you should be able to check in, like section 1.6, and like it'll say that that's what problems are for, and you should be able to click on it and have it take you to the text. At least that's how it's worked for me in the past.
Yeah, in the class announcements, he just made some recommendations to go over problems. I think it's in the announcement for the class, which is separate from the WebAssign assignments, which are generated automatically.
Is there a possible way? Sorry, this is too much to ask. If I can possibly like share my screen so I can ask you guys like to help me with it.
Yeah, sure. Why not?
By all means. Yeah.
All right. Hold on. Let me see if I can open this up. Option. How do I do this? All right. How do I share screen here? Usually it's up here.
Very bottom.
I might not have enabled it for. Shoot.
I see it. Alt S.
Hold S.
Alt S.
Oh, I'm using a Mac. Maybe.
Other than Alt, whatever that Mac equivalent is.
Okay, I upped you like in privileges, so maybe you should.
Mm-hmm.
View options, request remote control.
If you scroll to the bottom of the screen, maybe it pops up a menu.
It's been really weird. It just says view options. Usually at the very top, it would ask me to. Usually, the other person has to stop sharing the screen for me. Oh, I think right here, share desktop. I think I got it.
Right.
I don't know if you can probably see me. I'm in my cot right now. Not my cot, sorry, my tent. All right, can you see my screen?
Yep.
All right, so I had trouble with this one as well, but so when I open this, here's where I go into past assignments, and I go into homework, and this is where I was going off of. I was having trouble with this question 12, but we can go back to that one in a second to look at it. But what I mean is, how do I? This is the book right here, the text. If I open this up, and where are the questions itself? Because I just get this when I go to 1.6.
Keep scrolling down. Keep scrolling down. So this is the start of 1.4. So the concepts of 1.4. Try scrolling down. Like, do you have a wheel or some type of? Yeah, there you go. Mm-hmm.
Yeah, but it won't. Let me scroll down.
Keep going. So this is still concept. Still concept. Keep going. So far, it's the same. Keep going. Keep going until you see the next section. Show me 1.7. Keep going. There you go.
Oh.
Yep,
Okay.
1.6 exercise. Yep, that's it.
Is this something that we have to do?
No, this was recommended in the announcements, but I highly recommend, that you do it. Like, if you can't do this, then we're gonna have issues, no doubt.
Okay, I'm done. Okay, this definitely helps me out. Thank you, because I'm used to. I just finished taking math 20. What is it? Math 22 and math 26, and it's just all Alex, and it was so simple, it was straightforward. And I would just move it to this, and something else.
It is a little bit. I also, just like as an FYI, would highly recommend just doing all of the practice problems you can get your hands on.
Olivia, can I ask you about that? Like, so I noticed the answers are only the odd questions. Is there any way to find all the?
I think they're only in the instructor's book, which is really unfortunate. Typically, what I do is I get my hands on an instructor's book, and I do even questions in GSGs to kind of combat that. but Wolfram Alpha is your best friend.
Gotcha. Thank you.
If you really want to check your answers.
That was Wolfram Alpha?
Yeah. When my screen comes back, I'll write it down for you. And basically, it's just like math answers. It's like Google, but for math.
I used it for trig pretty much. It just helps you like it shows you the work so you understand the concept.
Yeah.
Gotcha. Olivia, I had another specific question.
Yes.
The perfect cubes. Can you go over the different forms, because I'm tripping up on the algebra, honestly.
Oh boy. Okay. Yeah. I can do my best to help with that. Go back up. This is the tutorial for number 12, yeah?
Yes.
Okay. I'm sorry, I'm writing down this problem.
Yeah, so that's what I was trying to say earlier. See how it splits it into a pairwise function, where if it's approaching from the right, it's x plus 5, and if it's approaching from, it helps people get over the plus. Like if you drew it out graphically, it would look like a V at alpha, because if x is -1, what is y? -1 times -1 is 1, so it goes up. You see, it forms a kind of V.
Mm-hmm.
So, yeah, so that's why that pairwise, when you break it up just like algebraically like that, that's why that works.
Okay. Yesterday I had trouble with this one. The good thing about WebAssign is that it lets you like resubmit your answer if you don't get it.
Yeah.
So I got lucky with that. I'm gonna scroll down to step 3 and 4. If that's all right.
Yep.
And there's one more after that.
Yeah, so it's approaching it from both sides, right? So from the left, it's negative x plus 4, or negative x plus 4. This way, it's just x plus 4 as it's written. So you're looking at the limit from both sides, from the right side and from the left side, approaching it from the right and from the left.
Okay.
Right? And in that way, you're graphing towards, hopefully, a limit.
Sorry, that's me. I'm just writing. I don't actually have like any control, but I was just trying to like point out the step 1 and step 2 is like very specifically taking it from the left for those people who are kind of watching retroactively. And then step 3, step 4, we've got this limit coming in from the right. So we're like, we have this in the left and we have an answer. Yeah. And this is the exact same thing we were doing earlier. And then here we have on the right, we have this answer. Answers are different, so they're not in existence.
Okay, so when the answer is different, they don't exist.
Yes.
The whole limit of x, this whole thing of x approaching -4 does not exist. That does not, however, mean that the limit of x approaching -4 from the right or from the left doesn't exist, because we just showed that both of those do exist. But these are like different and more specific than this is generally. Yeah? Does that kind of make sense?
Somewhat. Could you possibly do another problem and maybe do a graph? Because the way the last problem, seeing it visually, how Alexander recommended it, definitely helped me grasp it.
Yeah, for sure.
Yeah, let me stop sharing.
Okay. All right. So let's do. Sorry, I was looking through my other book, and it's like much less focused on like theory, and I think we spend like half a chapter talking about limits, and there are not that many great practice problems in there, which is super unfortunate. But let's do. Let me think. Okay, I'm trying to come up with. Give me just 1 second to come up with a good example problem, because I know exactly what I want this to look like, but I need to find a function that will make it look like what I want, which is not exactly the nicest thing to do. Also, I did try to get onto WebAssign, and they will not let me on. So that's just an FYI.
They're fake for that.
Adolfo, I was going to say, there's a couple of good YouTube videos that the teacher put up in the notes. They're really, really, really useful at explaining stuff.
Yeah, I saw the videos, the saved videos, the 3 videos by Professor Bang and Professor.
No. I didn't mean those. I meant they're it's a woman. She's like a professional YouTuber, and they're in the page that tells you all the work you're supposed to do, like what's.
How do you access that?
So if you go into Canvas, you open up Math 140, and you go to Modules, look at Week 1, open up Week 1, and then go through each one of those, and then some of them will include links to YouTube sites. And it's a young woman who presents. You'll know her.
Oh, I see them. I see them.
Yep. Mm-hmm. Those are really, really incredibly helpful.
Okay. Krista King.
Yes.
Okay. Cool. Anything that helps.
Sure.
Class just started, so anything helps. Any other classes you're taking, Alex?
Oh yeah. English 202D, Psych, and something. IST 301.
Oh shoot.
Yeah.
You're gonna be busy.
A little bit.
Is 202D engineering?
No, 202 English 202D.
Yeah.
Is, I think it's I think it's geared towards resumes, I want to say.
Okay, because like everyone has to take a different 202. There are like 12 letters or something for 202. Like I have to take 202C or something.
Interesting.
And my English major friend takes 202A. I think.
That's very.
So I'm trying to figure out where you guys are. What are you guys' majors?
Software engineering.
Software engineering.
Senior dual majoring, security risk analysis, internet cybersecurity option, and IST.
Cool.
Yeah.
That's a lot of computers.
Yeah, that was a lot of overlap too. Let me put it that way.
Well, hey, that's good.
Exactly.
I just want one where they're converging. Like, is this too much to ask to find a good example on the internet?
We can possibly be doing the same one if you'd like. I can possibly just look for it.
Looking for a function that looks certain.
I'm looking for something that converges. Like, instead of having something that doesn't exist because you take it from the left and from the right, something that does exist.
Converge at 0.
But I'm like thinking about it now, like objectively, that is just like a regular like limit. So
how about
I'm just making this infinitely more complicated than it needs to be, because I guess that's how I roll today. Let's think about something along the lines of This is going to 3, and this is going to be, gosh, I don't know. This is going to be x, no, this is going to be 2x minus 5, and this is going to be, I don't know, 3x. That's fine. The point is that x is approaching 3. The point where this would be 0 is x 5 over 2. So if x were to equal 5 over 2, then this thing would be 0. And so we have an asymptote there that we know about, right? So let's call that 1, 2, that's 2.5. So here's 3. And I'm going to change this to 4, so we're a little bit further away from the asymptote. Okay. So if x is approaching 4 from point is that if x approaches 4 from the left, it is the same as if x approaches 4 from the right. But we're going to go through both just to show that it's the case, which is a little tedious, but c'est la vie. So this is 3 times like 3.99. I'm just going to use 3.99 here. 2 times 3.99 minus 5. So this is approximately 12 divided by approximately 8 minus 5, 3. So it's approximately 4, yeah. So it is, this is just under, and this is also just under 3. So this is just under 4. So if, here, let's also do this. All right, so there's 1 point. So here's our 4. X is approaching 4. We're saying that it's going to be 4. And when we're coming from the left, it's approaching 4. Yeah?
Yes.
And it's approaching 4 from like 3.99. So we are A-okay here. Now we're going to do this again. We're going to have it approaching from the right. Basically what this is going to be is essentially the same thing, but it's going to be from a little above. So it's, both of them are going to 4, both from the left and from the right. So we can confidently say that the limit as x approaches 4 is equal to 4. Correct. Because both of these are the same number, and we're okay with that. And so we're not really seeing kind of like the kind of convergence. I really wanted something where they were like both going to like positive infinity from either side, but I didn't want to think too hard about it, I guess, because I had already taken up like 5 minutes of everyone's time thinking about it. So now let's think about, I don't know, not the limit, but as it's going to 5, that would be 3, 5, 2 times 5 minus 5. That's 15 over 5, 3. So here. So that's kind of what the function looks like. But this is kind of one of those examples where nothing really dramatic is going on. I wish all limits could be like this, because this is just our answer right here, and it's just if we're coming in from this side, we're approaching 4, and if we're coming in from here, we're approaching 4. So that is, like, here we don't necessarily need to do, like, the limit as x approaches 4, because the answer can just be 4. And that's
since both answers are 4, then they're similar.
Yeah.
So, like the last answer where 1 is 5, 1 was -5, so it does not exist.
Perfect.
Yes. And yeah, this does, like, x equals 4 also does exist. We can, I'm going to just kind of draw what I was envisioning with no function, because I guess that's how it goes. You can have something that kind of looks like this. And here the limit would exist without, I'm calling this 4, calling that 4. So we have an asymptote at x equals 4 now, and this is completely unrelated to any of this. This is just kind of my musings. But this limit exists. And the reason it exists is because if we come in from the left, it goes to infinity. And if we come in from the right, it goes to infinity. And so the limit is infinity.
Okay.
However, the function does not exist. There is no f of 4. And the reason that is because there can't be anything on this asymptotic line. So the limit can exist without the point existing, but the easiest way of kind of thinking about, like, something like this is here we have a point that exists and limits that are, like, coming into the point. So it's easiest to think about things when everything actually exists. But there are cases when it doesn't, and that's fine.
So when they approach the same value.
Yes, so they have to approach the same value for the whole limit to be the case.
Gotcha.
So you can have you'll notice I use, like, 3 instead of a. If that really bothers somebody, like, let me know. But I have a tendency to go with basic integers rather than letters because I think there's enough letters already. I'm a simple person. But so let's hypothetically have this limit be infinity and this limit be infinity. Then this limit 1 exists and 2 is equal to infinity because both of its subparts. It's the case. So here we have this different problem. We have 4 from the left. This is kind of reminiscent of a problem that we had looked at earlier, where this is going to equal negative infinity and this is going to equal infinity. This limit does not exist because these two are not the same. So these two can exist on their own and leave this one out to dry. So this doesn't need to exist for these two to exist.
Wait, why isn't the 3 plus on the left-hand side not negative infinity?
She's just saying hypothetically.
Oh, these are like hypothetical things. This is like,
Oh, okay.
Yeah. This is A. This is some number. I just don't like using more letters because I think they're confusing. But here, this will be B now. So these are different limits. And
I didn't mean to make you write letters.
No, it's good. It's good. If it makes you guys understand it better, then that's what I'll do. I just, I'm trying to make this as less confusing as possible. Because in my opinion, whenever you're reading through like a calculus or a math textbook, it's always so stressful. Because the language that they use is just so, I don't know, it's just confusing. So much. It's so much. And so whenever I do anything like this, it's always me trying to make it as simple as possible so that I can wrap my head around it. Anyway, So that is some of the limits. Do we have any more questions?
I do have questions from the book, but it's primarily like how you're allowed to alter the function algebraically. You know what I mean? Like
Yes.
the last question I gave you, I just factored it wrong.
Yeah. No, I'm going to say that you can do whatever you want to the function algebraically. Oh, that's not the question you were asking.
No, the question I was asking was,
Okay.
I need assistance.
Yes, walk through the algebra. Let's
Right.
do it. Give me some problems.
Sure, you ready? All right, limit as x approaches -2. In the numerator, we have x plus 2. And in the denominator, we have x cubed plus 8. And I can see they're being cute here, right? Like they clearly want to factor out the denominator into something like the numerator. So like x plus 2 to the third. But that would still leave us with 0, I believe. If I did that mentally, I don't know.
See, okay, algebra is not necessarily my strong suit.
No, me neither. That's the problem.
So,
would the bottom be x plus 8 cubed altogether, or is it just the x that's cubed?
Well, see, I don't actually know that. My guess, based upon how this is arranged.
How's the problem written
so
down?
That would be x plus 2 times x minus 2 would be the first move, because that would lead to x squared plus 4 minus 4.
What are you doing?
I was trying to work out a denominator like x plus 2 in parentheses to the third, right? But that doesn't work because it alternates sign.
How was the problem originally?
So it's the very top is the original
This
problem.
stuff in the black.
Yeah.
Oh, okay.
Okay.
So my next thought was maybe we can multiply by x cubed minus 8 over x cubed minus 8. See, that's the algebraic problem. And then distribute it out. Maybe. That's good.
Okay. I'm gonna show you what I did, which is not something you can do on exams, but this is...
Recorded.
Yeah, I'm aware. It's not something you can do on exams, but this is what I did, so I'm just gonna share it with you. Let me change my screen settings. Where is my share screen? Can I change it? How did you change your screen? New share. Got it. You want to see this. All right. And you all see Wolfram Alpha, my friend?
Yeah.
Ta-da.
My. Very good.
Yeah.
Okay.
So,
So how do we? So along those lines, how the heck am I supposed to know? How am I supposed to intuitively feel that that's the first step to get? Like, is there no way to work back?
I have no idea.
Yeah,
she hasn't received. Is this a question in the book?
Well, no, so this is what they. So this is what it factors out. And this angers me because. I'm one of those people who struggle with algebra and struggle with the algebra of. I struggled with it all the way through. So we know that to get an x cubed, we would need an x times an x squared. Yeah. So that's where we start. But that was just a good way of showing us that we really are working towards something that looks like this.
and I forgot what it was already, but we're going to figure it out.
Right, okay.
So
we got x cubed. So the next thing we need the x squareds to cancel out.
Wait. How did that become x plus 2 x squared?
Well, okay, so yeah, we're creating we're separating it into a different factorization. If she does this in reverse, you'll see that this adds up to x cubed plus 8. So all we're doing is changing it algebraically.
So the goal is to have this be equal to this, but there are numbers here that I would have to go back into Wolfram Alpha to find, and I just want to figure them out right now because now I'm starting to get punched by this problem.
Wouldn't it be x plus 8 in parentheses all cubed?
So yeah, that's what we're breaking. X cubed plus 8. We're changing this into multiple terms, polynomials.
So yeah, this is different from this does not equal this.
Okay.
Because here, this is going to be x cubed, and this is actually going to be 2 cubed.
Right.
So let's work with that. So this
is. Hold on. Let me explain that real quick. I did on this. What happens is you get x plus 2 times x minus 2. That changes the sign. So then you have to go back to positive. That's why that doesn't work. Work it out. You'll see.
Okay. All right. No, you're good. Okay. So I'm just going to do x times x squared plus 2 times 4. And I can't really do anything from there to factor it out. So I'm just going to scrap that. It's x squared plus something x plus, I think, 4.
So we know
that would make sense.
Yeah, the x squareds cancel out, right? So there's got to be.
So, and then we have our x cubed, and then what we need is
2x.
This.
Yep.
Wouldn't it just be 2x? I might know.
Okay. So
this has got to be a minus, right?
Yes, that has to be a minus.
Okay.
Yes.
So let's
minus x squared minus 4x. Sorry, plus 4x.
kind of drawing these circles, these bubbles, to show where my gap is.
Right.
And then that would be. So we have our x cubed and we have our 8. So what we have here is we have a 2. I'm going to call this a now. So we have 2x squared minus ax plus 2ax plus 4x.
What numbers?
No, I messed something up here.
What numbers multiply to 4, but when added, become -1? So I'd say 3 and 1. So plus 3.
3 and 1 are not going to be
-1. So positive. Sorry.
3, -4, negative.
Positive 3, positive 1. Yeah.
Where do you want those? I only have one a.
Sorry. If we did plus x plus 3, no, that wouldn't work. Sorry.
Okay. Okay. So we have x cubed. Good. 2x squared plus 2x squared.
Now we need
minus
2x. We need minus 2x.
Ax squared plus minus 2ax. I missed that x squared there. Plus 4x plus 8. So what we can do is we know that this is equal to x cubed plus 8. All right. Everyone knew how we got here, right?
Yes. Oh, yeah.
Okay. Because I think I just about solved it. Did it.
Okay.
Woo!
Congrats.
So let's just subtract x cubed and subtract 8 from both of these.
I have -3 ax though. Oh wait, no, sorry, the squared. Okay.
This is 2, yeah.
Gotcha,
So
yes.
so I just called this a, and this is the number I'm trying to figure out, because I knew I started off with this x squared, and I knew I had to end with a 4 because I wanted to do x cubed and no coefficient, and then 4 with no x. So what that leaves me with is 2x squared minus ax squared minus 2ax plus 4x is equal to 0. And so 2x squared minus ax squared is going to equal 0 because there are no x squareds. And then I'm also going to say that -2ax plus 4x is equal to 0. So here a is equal to 2, and here a is equal to 2. And we know we did it right because a is the same. If a were different, we'd have screwed something up. But it's the same. So,
putting back in for a, you get 2.
This is 2x, and this is 4.
4 times 2 is 8. So if you FOIL that back out.
So give me 1 sec. I'm gonna erase like all of this. Sorry, like sometimes I guess this is what you gotta do if you want to solve the problem.
No, exactly. No.
It's just really bad.
I really want to show you pages of scribble.
Okay, so let's just double check this. We have x plus 2, and we have x squared plus 2x plus 4. So that's x cubed plus 2x squared plus 2x squared. Sorry, I'm just doing it like this, and then I'm going to do the next 2 with this 2x here. So that's 2x squared plus 4x plus 4 minus. This is a minus. This is a minus. So this is a minus. And this is minus. So it's plus 4x plus 8. So those cancel, and these cancel. And we have x cubed plus 8. So we did it!
Oh, you know what? You know what I just realized?
What?
This is where the rule of perfect squares comes in. This is how
well, you know.
I know.
I thought he was going to tell you that he gave it to you wrong. I was about to say.
Oh, no.
I'm like, it was actually x3 plus 7, not
so,
plus 8.
like rule of perfect cubes, it'll give you like the AX format. Perfect. This.
Okay. I did not realize they made you know this.
You know what it was the other teacher who told us. He said if you memorize this rule of perfect cubes, he goes, it'll save you time. You don't have to know it, and this is exactly what he's talking about, right? Because this would take me an hour to do, or 5.
Well, I think the lesson we all learned here is the rule of perfect cubes is apparently useful on occasion.
Yeah, definitely.
Through that.
Who'd have thunk? Okay.
Right.
So now we can actually take this limit.
Very nice.
And we're going to do that really simply and really quickly just to wrap this up. Bam. So we have the limit of x approaches -2, and we have 1 over x squared plus 2x plus 4. So, this is not plus, this is minus.
Oh, yeah. Because in the blue, yeah.
Okay. So that's a plus. So this is going to be 4 times 3, 12.
16, 12. There it is.
Ta-da! She's Louie. Cool. All right. You said you had more algebra for me?
Oh, yeah. If you ask. Sure. Alfonso, did you have another question or?
No, I didn't have any more questions.
Okay.
That was pretty much it for me. But I still wanted to like observe whatever else you asked.
Sure. Number 21 asks the limit as it says h approaches 0. You want to write whatever you like. Okay. Then it's going to be the square root, and all of this is under the square root. 9 plus x. Okay, that's it. So n square root.
Okay.
Minus 3, still in the numerator. All over the denominator is just h. So I assume this is like a distribution type.
Oh, lordy.
Yeah, so like we multiply it by the square root of 9 plus x minus 3 over the, plus 3. Right, yeah. No, I'm sorry. The original problem is written as minus 3, so you had it right. I'm just saying that we're multiplying by the inverse. I'm dividing it by 9. How do I explain this? I'm dividing by 1.
Oh.
Right, and then I'm foiling out, and then cancel, and then because it squares it, right, and that gets rid of the square root.
Usually we do that to put square roots in the numerators, not in the denominators.
Oh, interesting.
That's why you end up with things like the square root of 2 over 2. And what that is 1 over the square root of 2, just multiplied by 1.
Okay.
Right? And so for some reason, mathematicians don't like it when square roots are in the denominators. Not sure why, actually. Nobody's ever really explained that to me ever. But
so the original problem was written out as square root 9 plus x minus 3 over x.
Mm-hmm.
And you said, how did you get a what's squared by half?
Yeah.
Oh, this is the exponent. So this stuff in here is to the 1/2. Like if it's x squared, x to the 1/2.
It's the same thing.
Yeah, and so something to the 1/2 is the square root of something. It just makes it easier to digest in terms of like, because like once you have this big old bar, like what are you doing with this? Right. I don't know what to do with that.
So
but this I can work with better.
Square root of the 1/2?
Yes.
Yeah.
Okay.
The exponent, yeah.
I've never seen that.
Yeah, no, you're going to be using this a lot later on in the semester. So square root of x is equal to x to the 1/2. Okay.
So 0 over 0 in its current form.
Mm-hmm.
Which is not acceptable. I see. Okay, so just follow me on this. If we multiply the numerator by the square root of 9 plus x minus 3, and then we also multiplied the denominator by the square root of 9 plus x minus 3, then our denominator would no longer contain a square root, because the square root, once FOILed out. Oh, no.
All right, let's go with the original gut plan. Or we'll see how this goes.
And I'm not sure if it's supposed to be plus x or not. Or sorry, plus.
It is supposed to be plus x, right? Here?
Right, but you can't. Yes. Yeah. Oh, you've got it written right. Yeah.
Okay. All right. Okay, so this is going to leave us with.
Did you include the coefficient? So it'd be like either plus or minus 3 as well up there.
I didn't initially, and I did that on purpose. But now that you're saying that,
sorry.
I'm thinking that perhaps might be a good idea.
Yeah, I believe it's included. Because think about it, it's a certain number, minus 3, right? You'd have to. Well,
so what we would do is we'd multiply this by this. The square root times the square root, we're going to end up with the 9 plus x.
Right.
Then we'll end up with minus 3, and then we'll just have 9 plus x here. And then down here, we're going to have x x, 9 plus x. So let's do it with the -3, but that's not gonna, because then what we're gonna end up with is, yeah, that's not gonna help.
Well, see, okay, no, if you did +3, right? Because you're dividing. You're not dividing a fraction, right? Right. Then see, they cancel out those terms, and then you're left with -9. See, it's you get +3 times this square root, and then you get -3 times this square root. Those terms cancel, and then you get -9 on the numerator.
Not following, and that's probably just a me problem.
So if we foil the square root of 9 plus x times 9 plus x, we get well, essentially we get the square root cancels, right? Right. Now,
oh yeah.
Perfect. Okay. So
Cool. I see what you mean now. And so this is going to be +3x here on the bottom.
Right.
Cool. These 9s are going to cancel out.
Right.
So what we're going to end up is x
over. See, this is where I get, and then I tried to plug in, but it's still not right.
Pull out that x. So we have 9 plus x to the 1/2 plus 3, and then we're just going to put that in brackets. So I pulled that x out of here and here. Yeah, 2 minds together.
Yeah, just didn't factor out the x.
The x will cancel out.
How did you pull out the x if it was already out?
1 x here, and I had 1 x here, and so I just pulled the x out of both of those and put brackets around this whole thing. So if I were to distribute the x, I would end up with x times 9 plus x to the 1/2, and then I'd also distribute the x over here, so I'd end up with +3x, which is exactly what I have over here.
I'm
if
following.
You took x out, wouldn't that be x squared? Oh wait.
I agree with him. I'm following this now. I don't understand what's happening there.
Wait,
Okay.
if you take.
Okay, so okie dokies. So I'm just going to rewrite this.
Mm-hmm.
I'm going to do that. I'm going to have x, and then I'm going to write this as 3x plus x times 9 plus x to the 1/2. Yeah? Okay. So what I'm going to do is in this bottom part, I have x times something here, and I have x times something here. So I'm going to say this is x times the quantity 3 plus 9 plus x. So it's a big bracket-like thing. It's not like a simple parentheses, but the x is on the outside because I do have an x times 3. So if I were to distribute this back in, I'd end up with x times 3 plus x times 9 plus x to the 1/2.
Okay,
so
you rearrange the numerator there. Help me understand.
So I rearrange what?
No, say you're rearranging the numerator there. I mean, sorry, the denominator there. Help me understand.
Okay.
Because when you originally had the 9 plus x on the left-hand side.
Oh, like, yeah, no, I moved it so that you could kind of see better the fact that we just had an x times an x here. So this is exactly the same here and here. I just swapped it so that it might be easier to see, which I'm now regretting.
Yeah, yeah. I just substituted, and it was just slightly too high.
Okay. So.
Yeah. So you had it right. You just had 1 x too many.
I did? Oh, well.
Sorry, I'll be quiet. I'll just let you do this. I'm really honest to God. I'm just shut up.
Okay. So, and another way of putting that in is if we didn't distribute it at all to begin with.
Right.
We just multiplied these through, and we ended up with this canceling everything out. And then this is just x times this chunk, right?
Right.
And I'm not even going to distribute the x because I don't really care. Because then I'm going to be able to cancel it out.
Right. Yes.
So cancel out the x's, and then what I end up with is
1 over the square root plus 3. Yeah, that's the right answer.
ta-da! Algebra.
So then we get 3 plus 3 and 6. Yep, perfect.
Sweet. So.
God, thank you so much. Really.
Yeah, for sure.
I didn't. So yeah. Pull out the x. And so that very first step where we multiply plus 3.
Mm-hmm.
The way I understand that is we're dividing. Could you give me a simple fraction?
Oh yeah. Yeah. Okay. So so if we're gonna like just basic like multiplying fractions versus dividing fractions type thing. So if we're multiplying, then we're just gonna kind of go straight across. Like if we had, I'm gonna kind of make this a little reminiscent of the last one.
Mm-hmm.
So we're multiplying, and let's multiply it by 2x over 1. So we're just multiplying it by 2x, right?
Mm-hmm.
So what we can do is we can just add that into, it's like numerator times numerator and denominator times denominator here. So it's 2x times 9x minus 3. Let's say now that we want to divide
over x
by 2x. What we do here is we can, this is the same as multiplying by the reciprocal. I put x and just put a dot. So this is going to be, this is going to be 9x minus 3 over x, 2x squared. 2x times x.
Right.
Okay. Yes.
Okay, so in the last problem, if
Mm-hmm.
you remember, we multiplied by the numerator, and the numerator changed signs. The coefficient changed signs. It was,
yes.
It was originally plus 3. It became the square root of 9 minus x minus 3. Right.
So that's 1. So what we're going to do here is we're going to do, we're basically just going to FOIL it. We're going to have 9 plus x to the half times to the half. So that's 1/2 plus 1/2 rules of exponents. Or we can just think of it as square root times square root is equal to the actual number. So we have 9 plus x, and that's our first chunk. So this one times this one. Then we're going to do -3 times 9 plus x to the half. So that's -3 times 9 plus x to the 1/2. And then we're going to do this one. So that's plus 3, 9 plus x to the 1/2. And then finally, we're ending it with this. So that's plus 9. Yeah?
Minus 9?
Minus 9.
Sorry.
Do not apologize for correcting me. Because I would walk through that whole problem with that plus 9.
We're all tired. That's what
okay. So, and I'm not going to worry about the denominator for right now, if that's okay. I'm just going to simplify this top part first. So that's 9 plus x, and then this chunk and this chunk.
Mm-hmm.
We have a negative and a positive. I'm going to cross them out because these are exactly the same thing, and it's just one minus the other. So it's
plus
0.
3 square root of 9 minus plus 6.
So, yeah, and then minus 9. So that allows us to cross out those 9s. And that's how we ended up with x in the numerator. And then the denominator is we just multiplied. So we just multiplied this top and then this right like that.
Got it. So in order to divide, we change the sign.
In order to divide.
Yeah, so like, so the numerator of the original problem, we're multiplying by its inverse, 1/3.
It's not actually the inverse.
Okay.
We just went with that plus 3 so that we could counteract this during the FOIL.
Oh,
This negative and this positive. The reason it's not about multiplying and dividing, it's about when we're FOILing it out.
Right, we're eliminating it.
Yeah, what we want is these two to be gone.
Right.
And so it's kind of like if we have x plus 4 times x minus 4. So that's x squared plus 4x minus 4x minus 16. So it's x squared minus 16 because these cancel out.
Right.
So this is what the grand scheme of things, like that was the plan with what we did. What you did that. But so this was the plan, and that's how it turned out with these 4 x's, or in this case, this big long chunk getting canceled out. So we didn't have to worry about it.
Got it.
All right. Any more questions? Otherwise, we can.
They covered all of mine.
Awesome.
Yeah, I don't have any questions either. You pretty much covered all mine.
Sweet. That's what I like to hear. Next week, I will be more prepared with the book, so we can actually go over questions that are in the book.
Cool.
Thank you so much. Same time next week?
Yes. Same time next week, 7 p.m.
Awesome.
All right.
Thank you so much.
Yeah.
Right. See you, Olivia. See you, Alexander.
Thank you.
You guys have a great night.
You too. Bye.
Thank you, Olivia. Bye-bye.